Examples. Problem solving with fractions. So we're going to look at each one of these problems and we're going to decide if we're multiplying or dividing. We're going to solve it out as well. So the first one says, Olivia cooked 8 cups of pasta. How many 1/3 cups are in half of this amount of pasta? So there's some things that we need to underline. First, we need to know that we have 8 cups of pasta. We want to do 1/3 cup servings, but we're actually looking for only half of the amount of pasta. So in this case, there are 8 cups of pasta. We want to know what is half of 8. So 8 divided by 2, because half of that, and we get 4 cups of pasta. We want to know how many 1/3 cups servings are there in 4 cups of pasta. So in this case, we are going to take the 4 cups and we're going to break them into 1/3 cups. So breaking them means we're going to divide. We're going to be doing some division. So this is a dividing problem. So first things first, we're going to follow the method of keep, change, flip. So KCF. First thing we do is keep the first one the same. So instead of keeping it as a whole number 4, I'm going to put it as a fraction. So I'm going to do 4/1. We're going to change the sign to multiply. And then we're going to flip or do the reciprocal. So 1/3, the reciprocal is 3/1. And now we have a multiplication problem where we just multiply straight across. So 4 times 3 gives me 12. 1 times 1 is 1. So we have 12/1, or 12 divided by 1, which is the same as saying 12. If you wanted to model this, in order to model, you will need to show your 4 cups of pasta. And it's best to do this as bars. So we have 1 cup, 2 cups, 3 cups, and a 4th cup. And we're going to take those 4 cups and we're going to divide them into thirds. So we need 3 sections. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And so each of those is a third. We want to know how many thirds there are. So you just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 1/3 in 4 cups. Our next problem is right over here. Luke raked leaves for 4 days. He worked for 3/4 of an hour each day as shown in the model below. How many hours did Luke rake leaves? So looking at this question, how many hours did Luke rake leaves? We are actually looking for a total. We are looking for a total. So that right there, if we're looking for a total, tells me that this is a multiplication problem. We're going to be doing some multiplying. So let's look back in the problem. Luke raked leaves for 4 days. So we have 4 days as our whole number. He worked for 3/4 of an hour each day. So we have our 4 as our whole number times 3/4 of an hour each day. And we want to know how many total hours that Luke raked leaves. So first things first, we take our 4, our whole number, and we're going to put it over the number 1 to make it a fraction. So 4/1. In this case, it's multiplied, so we leave it as times. And since it was originally multiplied, we're going to leave the second number as 3/4 of an hour. And now we multiply straight across. So 4 times 3 gives us 12. 1 times 4 gives us 4. So now we have the improper fraction 12 divided by 4, or 12/4. And to solve that, we are going to divide. So we have 12 goes inside the house, the numerator. 4 is our divisor. 4 can go into 12 3 times. So the answer to this problem is 3 hours. Luke raked for 3 hours in those 4 days. The next problem says Mrs. Ling has one half of a gallon of milk left in the jug. She pours an equal amount of milk from the jug into each of 5 cups for her children. What fraction of the entire gallon of milk will each child receive? So, some things about this one. The question says, what fraction of the entire gallon of milk will each child receive? So right there, we know that our answer should be a fraction. It tells us what fraction is what we're looking for. We know how much Miss Lynn starts with. She starts with 1/2 gallon, and she's going to pour it equal amounts into 5 jugs. So if we're pouring it or distributing it equally, that tells us we are going to divide. We're going to divide. So Miss Ling is going to start with 1/2 of the jug of milk. She's dividing it into 5 cups for her children. So we're going to do 1/2 divided by 5 to see what fraction each of the kids will get. So we follow keep, change, flip. So we have 1/2 stays the same. We change the sign to multiply. And because it's a because it's a whole number, we're going to change it to a fraction. So it's 5/1, but when we do the reciprocal, it becomes 1/5. Then we multiply straight across. 1 times 1 equals 1. 2 times 5 equals 10. So each child is going to receive 1/10 of the original jug of milk. If you needed to model this, you could model this with, again, just a rectangle. Take a rectangle and you're going to cut it in half because we're going to start with 1/2 of our milk. So I'm going to shade in 1/2. It has milk in it. And then each kid, we're going to divide it into 5 sections because each kid's going to get the same amount. So we're going to have to make 4 cuts, 4 lines. And I know they're not going to be even, but we're going to do 4. 1, 2, 3, 4. And we want to know how much one kid is going to get. So even though it's not equal right there, we could count. We have 1 out of how many potential cups? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each child gets 1/10 of the milk. The last example says Maria gave away 4/6 of her 18 sugar cookies. How many cookies did Maria give away? So the problem wants to know how many did Maria give away. So that means we are looking for a total. When we are looking for a total, we know this means we are going to be multiplying. We know that she gives away 4/6 of her 18 sugar cookies. So we want to know, what is 4/6 of 18. We want to know 4/6 of 18. So if we look at this, we have to find how many groups we will need. Well, if we look here, our denominator tells us how many groups we should have. We should have 6 equal groups. So if I go across, that's not going to give me 6 equal groups. That only gives me 3. So I have to figure out what this is. So I need to find out how many need to be in each group. So if I did that, I would take 18 and divide it by 6. 6 can go into 18 3 times. So for there to be a group, I need 3 cookies. So I have 1 group, 2 groups, 3 groups, 4 groups, 5 groups, 6 groups. Well, if we're going to do 4/6, I need 4 out of the 6 groups. So this is 1, 2, 3, 4. And all we need to do is figure out how many cookies that is. So if we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So Maria gives away 12 cookies. Let's see if that's correct. Let's do the computation. 4/6 of 18. So of, again, means to multiply. 18. And we want to know, what is that equal? So to start, we have to take that whole number and put it over the number 1. Then we're going to multiply straight across. 4 times 18, and I'm just going to do this off the top of my head, is 72. But if you need to do side work, it is perfectly fine to do side work. 6 times 1 gives me 6. So we're left with an improper fraction, 72/6. 72/6 is the same as saying 72 divided by 6. So if I have 7 cookies and I need to make a group of 6, I can do it 1 time. 6 times 1 gives me 6. 7 minus 6 is 1. I bring down my 2. I have 12 cookies and I want to make groups of 6. I can make 2 groups. 6 times 2 is 12 equally. There's none left over. And the answer to this is 12 cookies. 12 cookies, which is exactly how many there. Cookies. So that's how you can model and prove it by doing your computation, your algorithm.